Okay, the last section of Unit 2, 2.9. Solving simple equations that have rational exponents. This is going to be very similar to what we just did. Just one little twist on it. So remember that x to the 1/2 means this. We don't need the 1 and the 2, but that's what it would look like if we did. And 1/3 is the cube root of x. And it would look like this if we fully expanded it with all the details. So, if you think about yesterday's notes, the previous day's notes, we had radicals, and our first step was to get the radical alone. Well, notice here, we don't have radical form, we have exponent form. So the first step is to write in radical form if it's 1/2 or 1/3. And then pretty much it's going to be the same as 2.8. So we're going to start off by writing the cube root of 2x minus 3 plus 5 equals 7. Now we're at 2.8. That was the only thing new, really, in this section, is changing from this to this. Now we minus 5 on both sides, and we get the cube root of 2x minus 3, don't lose the radical, equals 2. Now, to get rid of the cube root, we cube. Okay? It's kind of like a tornado that comes and just rips the roof off the house. Okay? That's what's happening here. The 3 comes in and gets rid of the cubic root. And we just do that to both sides. Make sure you show that, please. All it leaves us with is 2x minus 3 equals 8. 2 times 2 times 2. Add 3 to both sides. 2x equals 11. Divide by 2. X is 11 halves. Now we have to take that number and plug it back in to our original equation. Okay? 11 halves times 2. The 2's canceled, which leaves us 11. Or 2 times 11 is 22. Divided by 2 is 11. Either way you process it. 11 minus 3 is 8. The cube root, or 1/3 root of 8 is 2. And 2 plus 5 is 7. Check. No extraneous answer. So, a little bit more. Same thing. Rewrite it. 6. X plus 8 goes underneath the radical. 1/2. We don't have to put the 2 there, but that's what it means. Minus 4 equals 8. Now I kind of got that minus 4 a little bit over underneath the radical. Don't want that minus under there. So it looks like that. Now we add 4 to both sides, and we end up with this. Then we're going to divide by 6 on both sides. And now, radicals alone, we square it. Both sides. Bam, it's gone. X plus 8 equals 4. Subtract 8, x equals negative 4. Gotta check it. 8 minus 4 is 4. 4 to the 1/2 power, or the square root of 4 is 2. 2 times 6 is 12. 12 minus 4 is 8. Check. Get rid of the 8. After we rewrite it, sorry, equals the cube root of x plus 3. Underneath radical. Plus 8. We're going to minus 8 from both sides and get negative 4 equals the cube root of x plus 3. This is okay, since it's a cube root. We can have the cube root be equal to a negative number. It cannot be a square root. There's no such thing. But cube root works out. So now we have it alone. We cube this side, cancel that, and we cube this side. Negative 4 times negative 4 is positive 16, times another negative 4 is negative 64, equals x plus 3. We're going to subtract 3 from both sides to get x equals negative 67. At this point, we plug it back in. Negative 67 plus 3 is negative 64. The cube root of that is negative 4. Plus 8 is positive 4. Check. It works. Example number 4. We have 6x plus 27 all underneath the radical square root equals negative 6x plus 27 equals x squared. We need to move these two over here by subtraction, since they're both positive, which gives us x squared minus 6x minus 27 equals 0, which we now factor. We need two numbers to multiply to give me 27. One's got to be negative, one's got to be positive, because it is negative 27. And that's got to be pretty much 9 and 3. Since we want negative 6 left over when we add the two inside and outside terms, we need this to be negative and that to be positive. Now at this point, we set them both equal to 0. And we test them both. X equals 9 and x equals negative 3. So we're going to plug that back in right here. 9 times 6 is 54. 54 plus 27 is 81, and the square root of 81 is 9, which we would be plugging in over here. So 9 is a true statement. We plug in negative 3. 6 times negative 3 is negative 18. 27 minus 18 is we're plugging in negative 3, sorry. Lost my train of thought for a minute. Negative 3 times 6 is negative 18. 27 minus 18 is 9. The square root of 9 is 3. But we're plugging in negative 3, so we end up with the statement 3 equals negative 3, which is false. So this answer is extraneous. 9 works, negative 3 does not. Okay, 7 equals 2 times the square root of x. Okay, remember, the 2 is not under the radical. It would have to look like that for the 2 to be with the x underneath the radical, which we do not have. So the 2 is outside, it's coefficient, plus 5. We're going to subtract 5 from both sides, we get 2 equals 2 radical x. Divide 2 on both sides, we get 1 equals radical x. Square both sides, have to do deciding here, we end up with x equals 1, because 1 times 1 is 1. Plug it back in. Square root of 1 is 1 times 2 is 2, plus 5 is 7. Check. Okay, example number 6. We have 2x minus 7 underneath the radical equal to 4x minus 31 underneath the radical, square root of both. So this is just like problem we had yesterday, square of both. That gives us 2x minus 7 equals 4x minus 31. That's supposed to be a 1. So what I'm going to do is I'm going to minus 2x on both sides. And I'm going to add 31 on both sides. Cancel, cancel. Leave me with 2x equals 31 minus 7, which is 24. Divide by 2, x is 12. I need to plug that back in here and here. 2 times 12 is 24. 24 minus 7 is 17. So we have the square root of 17 equal to, let's see what we get. 12 times 4 is 48. 48 minus 31. 48 minus 31 is also 17. We could turn that into a decimal, but why? If radical 17 is definitely equal to itself, that means 12 is a correct answer, not extraneous. Okay, so now we want to go one step further. And sometimes it won't help us to write it as a radical. And with 2/3, not going to help us. So, I'm going to show you 2 ways to do this, and they're both pretty much the same. It just depends on how you want, what you're more comfortable with. So I have x to the 2/3 minus 6 equals 10. First off, just like before, I want to get rid of the 6 and get x to the 2/3 equals 16. Now at this point, I have 2 choices. I can multiply, or not multiply, but take the power to the power of the reciprocal, which is 3/2. And when I said I slipped with multiply, it's because when you do a power to a power, you multiply. And 2/3 times 3/2, they cancel each other. Remember when we have fractions in front of variables, we multiply by the reciprocal to undo it? Because we get 1. So that leaves us with x equals 16 to the 3/2, or 16 to the 3/2. So the square root of 16 is 4, and 4 cubed is 64. Another way of thinking about this is, like I told you, we can write it like this. And if we take 16 times 16 times 16, we'll get 4,096. And the square root of that is 64. But we have to think about the fact that it could be, we're taking the square root, it could be plus or minus 64. Okay, because negative 64 times negative 64 is also 4,096. And we have to check both of these. So we're going to plug both in. 64 to the 2/3. Okay? As we said, 64 to the 2/3 means the cube root of 64, which is 4, squared is 16. And 16 minus 6 is 10. So positive 64 works. Okay? Now, negative 64. The cube root of negative 64 is negative 4. But when we square that, we get positive 16 minus 6 is 10. So both positive and negative 64 work out. Those are our answers. And the reason it works out is we're taking the cube, we're cubing it. Okay? It works out that way. Okay, another way of doing this is you can also just take the power to the denominator so that the 3's cancel, which then leaves me with x squared equals 4,096. You plug that in your calculator and you get x equals 64 and negative 64. So it depends on which way you want to look at it. You're basically mathematically doing the same thing. Some people find the second way a little bit easier because you're getting rid of that 3 and then you just have a square number and then you take the cube root of the square root of the other side after you cube it. But we're doing the same thing over here. We're square rooting and cubing, or we're cubing and square rooting. We're getting the same number. So it just depends on what you're more comfortable with. Let's try this one. We're going to add 7 to both sides. We get 2x to the 3/2 equals 54. Divide by 2, x to the 3/2 equals 27. Now once again, we'll do it both ways. I could multiply by, I could take it to a power of 2 on both sides, and get x cubed equals 27 squared, which is 729. And then take the cube root of that, which is 9. Negative 9 is not an option, because negative 9 times negative 9 times negative 9 would be negative 729. So 9 is our only option. And we plug that back in right there, and we take the square root of 9, 3, and cube it, which is 27, times 2 is 54, minus 7, it checks out. Or we could take 9 and cube it, 729, take the square root, 27, minus 7, and get 47. It works out. Again, we could have done it this way. I'm not trying to show you too many different things. It just depends. Some people like one way over the other. So in this case, those cancel, giving us x equals 54 to the 2/3. Okay? So I copied the wrong number. It should be 27. Maybe something didn't work out, right? Again, as you can see on the left side, 27 squared is 729. The cube root is 9. You get the same answer. So like I said, however your brain processes it, whichever is easier for you to understand, go with that. And last but not least, we have this nice formula where L is our length, and we're given the length of 1.7 meters. So we do 1.7 equals 0.46 times the cube root of m, which we're trying to find the mass. We divide both sides by 0.46. We're going to get a decimal. It's approximately 3.7 rounded equals the cube root of m. We just end up cubing that number to get m. And when we cube 3.7 to the third power, we end up with 50.65 rounded. Come on, kilograms.